Okay, so let's get into some trends in compound formation. All right. So we talked about the structure of the nucleus, the protons and the neutrons. And that's what makes unique atoms, and then, of course, unique flavors of those atoms. But it's really the way that these atoms form compounds, the trends, that give them their unique chemical properties. Okay? And that is all about the electrons. Okay? So I'm going to write all about the electron. So this is symbol for electron. Okay? When we get into the trends of compound formation. So for example, if I look at sodium here, and you notice that in this reaction, we've got the mass number and the atomic number, but that doesn't change the number of, the number of electrons don't affect those numbers off to the left. Okay, so I can still simply write sodium, so neutral sodium, right, which we know is going to have 11 electrons, and I know it has 11 electrons because it's not charged and it has 11 protons. Okay, so that number, right, tells me 11 protons. So now when sodium loses one of those electrons, it becomes sodium plus. We call that a cation, not a cation. Cation for positive charges. Now this sodium plus cation only has 10 electrons because it lost one. And the reason why it's not positively charged is because it still has 11 protons, but now it only has 10 electrons. So if it has 11 protons and 10 electrons, it has to have a positive charge. Okay. Well, what about chlorine? Well, chlorine, we recognize, because it has 17 protons right there, has to have 17 electrons. But now if I add an electron to it, right, this is still going to have 17 protons, but now it has to have 18 electrons. So 17 protons to 18 electrons means it is -1. And we call that an anion. So cation's positive, anion's negative. And if I combine these, a sodium plus and a chlorine minus, they're like two peas in a pod. Opposites attract, right? It becomes sodium chloride, which I'm going to put a little indicator there for solid. And this is what a sodium chloride looks like. Okay? The sodiums are orange and the chlorines are green. We'll learn throughout the semester that the cations become quite small and the anions become quite large. Okay? And because of the way that these are positive negative, they have to be they have to alternate. You can't have two positive sodiums next to each other or two negative chlorines next to each other. So it's got to be like, you can see they're diagonal, right? But they still have positive negative, positive negative, positive negative. And because of that arrangement of these ions, it gives it its bulk crystal structure, which is pretty cool. So sodium chloride on the bulk looks like a cube, a little crystalline cube. That's because if you shrink yourself down to the size of one of these atoms, it is cubic with the way that these atoms pack together. We'll explore this more throughout the semester. Okay. So what we just described was ionic compounds. Compounds that form because of the mutual attraction between opposite charges. So we'll say mutual attraction of opposite charges. Okay? Covalent compounds, on the other hand, form from sharing electrons. Okay? They are covalent. So I know valent might not be obvious what that term means, but you could think of it as like codependent, right? The compound cannot form if it did not depend on the other atoms. So the other atoms depend on each other to form this compound. They're covalent. Ionic compounds, on the other hand, only form due to their mutual attraction from opposite charges. Okay? So there's a huge difference between this, and we'll spend a lot of time going down this rabbit hole discussing this. Okay? Okay, so based on the position of an atom in the periodic table, we can predict what its likely charges will be when it forms a compound. Okay? So I'll say that again. Based on the position of an atom in the periodic table, we can predict what kind of charge it will have when it forms a compound. All right. So, for example, what do you notice about group 1 here? They're all +1, always. Okay? Group 2, all +2. Okay? So we can start to say that. All 1+, all 2+. Another one that we can definitely say, the halogens, when they form compounds, all 1-. So we can count on those, and I think, do I have that in a, I might have that in a summary slide coming up, okay? So group 1, we can always pretty much count on them being all +1. Group 2, we can all count on those being 2+ for their charge, okay? The halogens, we can all count on being -1. And then now here's where things start to change, okay? So you notice oxygen, sulfur, selenium, and tellurium are all -2, okay? We can expect that usually, most of the time. And you're going to hear me often say chemistry is the science of exceptions. So there's a lot of exceptions to these rules we're going to have to learn. But for now, we'll take it one at a time, okay? So you can see these 4 are almost always 2-. So we can kind of think of it as 0, -1, -2, -3 for nitrogen and phosphorus, but not for anything else in this group 15, okay? Similarly, now if we look at group 3, scandium and yttrium are 3+, and titanium is 4+, and so forth. But now look what happens with vanadium. Vanadium can be 5+, but it could also be 3+. And look what happens with chromium. It's not 6+, it's 3+. And manganese can either be 2+ or 4+, okay? So these transition elements that I'll box up right here, for now I'll just box these, right? They can be variable. So when they form compounds, their charges are variable. You don't have to memorize them if you know how to figure out what it should be. And we're going to spend a lot of time going through that. But you still should have some kind of familiarity with the common flavors. Iron is almost always 2+ or 3+. Rarely, if ever, would you see iron 8+, for example. Similarly, copper +1 or +2. Rarely would you ever see copper as, 4+, for example, okay? So, but as we go through this, there will be some that I do expect you to know, and some that I expect you to be able to figure out, okay? So let's go through that. And so, excuse me, I'm going to circle in red some of the ones that I think you should know, okay? These ones. And these ones. These you should know, okay? Red is stuff you should know. These ones. All right? I'm going to erase this line so it's a little bit more clear, okay? These 3 you should know. Because aluminum is always 3+, gallium is always 3+, and zinc is always 2+. Okay? And these 2 I want you to know. Silver is always +1, and cadmium is always +2. All right? But for example, like this lists titanium as 4+. There's also other flavors of titanium. So this isn't showing you everything. But what I've got in red now, red, you should know. Okay? So these areas, you should know these charges. All right? So let's move on.